In this video, we're going to talk about rational exponents. What is a rational exponent? We're going to be looking at exponents that are in the form of a fraction. And the way this works and what's really important about this fraction is to remember that the denominator is going to be what's called your index. Okay, so your denominator is your index. That is exactly what's going to go inside of your radical. So whatever n is, then this is just a to the n power inside the radican. So there's different ways for us to simplify a problem. If we take a look at an example, like let's say we have 16 to the 1/2 power. This one's actually a pretty easy one. This means the square root of 16. Technically, this 2, the denominator, goes inside of the radical sign. And of course, this is 16 to the 1 power. Now, this is just the square root. The square root happens so much. I mean, we work so much with the square root of numbers that you're going to see that you're not going to have a 2, which is the index for the square root. But you're not going to see it in problems, okay, because it's used so often. So when you just see the square root of 16, it is understood that we're looking for the number that multiplies by itself 2 times. It's going to give me 16, which of course is going to be 4. So the way we write this now with a rational exponent is 16 to the 1/2 power. If you were to try to simplify 9 to the 1/2 power, that's a square root of 9, which is 3. 25 to the 1/2 power, that's going to be the square root of 25, which is 5. What do you think happens when we want to take 8 to the 1/3 power? So 8 to the 1/3 power, this means the cube root of 8, or 8 to the 1 power, which is just 8. And then, of course, the cube root of 8 is 2. What number times itself 3 times is going to give me 8? 2 times 2 times 2. Okay, let's take a look at an example. Let's say we are asked to evaluate 8 to the 2/3 power. How do we do this? This is the same as saying the cube root of 8 squared. Of course, 8 squared is just 64. And the cube root of 64 is 4. 4 times 4 times 4 is 64. Okay, so the cube root of 64 is 4. There's another way that we can also do this problem, and that way is going to be, let's go ahead and still rewrite this as the cube root of 8, but this time we're going to put the square on the outside. And I will tell you that I actually end up doing it this way most of the time, just because sometimes what goes inside of this square root here ends up being a really big number. Right now, the 64 wasn't that big, but sometimes it does get big. So I rather take the root and then I'll either raise it to whatever power it is. So in this case, this is going to be the cube root of 8, which is 2, and then 2 squared is 4. So notice how we got back to exactly the same answer. So let's go ahead and take a look at this problem. It says 64 to the -1/3 power. When we talk about negative exponents, I do have a video on the rules of exponents. It would be a great refresher for you if you don't remember these. And I'm going to go ahead and link it in the description below. 64 to the -1/3, whenever you have a negative exponent, the way you get rid of the negative exponent is to do the reciprocal. So in this case, 1 over a to the n power. If I had 1 over a to the -m, and that happened to be in the denominator, the reciprocal is going to make it come to the numerator, to the top. So that's how you get rid of a negative exponent. So in this particular case, we're going to start by rewriting this as 1 over 64 to the 1/3 power. 64 to the 1/3 power just means 1 over the cube root of 64. And of course, we know the cube root of 64 is 4. So this is my final answer. Take a look at your screen. On your screen, on the left-hand side, I've written what are called the perfect squares. It is such a great idea for you to memorize the perfect square. I mean, I've only written from 1 squared all the way to 12 squared, but you can memorize all the way to 20 squared or even more than that. It just makes it so much easier when you're starting to do some of these problems if you can recognize perfect squares. And on the right hand side, I've written for you the first 10 perfect cubes, so that when you see a problem like the cube root of 343, you can think, oh yeah, I know that's going to be 7. Otherwise, you're fumbling with your calculator trying to figure them out. Other ones that are helpful for you to know are 2 to the 4th power is 16. 2 to the 5th power is going to be 32. All you're doing is multiplying by 2 again. 3 to the 3rd power on your screen, you can see right there is 27. 3 to the 4th power is going to be 81. 3 to the 5th power is going to be 243. So again, if you can at least start to recognize some of these, it is going to make the computation a lot easier. Take a look at the equation that you see on your screen. We are now trying to solve for x by working with these rational exponents. On the left-hand side, I see x to the 3/2 power. On the right-hand side, I see 512. One of the things that we can do to get rid of the exponent on the left-hand side of the equation is to raise both sides to the reciprocal. Reciprocal is what we call it when we basically flip the fraction. So the reciprocal of 3/2 is going to be 2/3. When you multiply a fraction by its reciprocal, you're going to end up with 1. And that's basically what we want here. We want to be left with x to the 1 power, which is just x. So what I'm going to do right now with this problem is that I'm going to raise both sides to the reciprocal 2/3. On the left-hand side, this becomes 6/6. So those exponents just cancel because that becomes 1. And I'm left with x equals 512 to the 2/3 power. The 2/3 power means the cube root of 512 squared. The cube root of 512, hopefully you remember from that list that we saw. If not, let's go ahead and take a look at the list. What would be the cube root of 512? The answer is going to be 8. So we know here that the cube root of 512 is 8. And now 8 squared is 64. So that means that 64 to the 3/2 power is going to equal 512, and we've solved our equation. All right, let's try another equation where we have these rational exponents. In this case, I have x plus 4 to the 5/3 power is equal to 32. You have to be very careful here because I know maybe you want to subtract 4 from both sides, but you can't, okay? You can't subtract 4 because of those exponents that are right there. So instead, what we're going to do is raise both sides to the reciprocal power, which in this case, the reciprocal of 5/3 is 3/5. That is going to cancel out on the left-hand side those exponents. So now I'm left with x plus 4 is equal to 32 to the 3/5 power, means the 5th root of 32 cubed. The 5th root of 32 is 2. 2 times itself 5 times is 32. So now I'm left with 2 to the 3rd power. X plus 4 is equal to 8. So x is equal to 4. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.